recording has started because I have raised it. It's not showing much. Oh, no, okay, thanks. Right. So as I was mentioning that we are more familiar with this kind of computing where you have a precise algorithm, precise in the sense that for a particular problem, as a solution, we know that for the problem, what is the input and what is the output. And similarly, when you solve it in the algorithm, so algorithm also is a solution to that problem where if you perform those steps of computations with certain input, you also can compute what should be the output. So there are precise definition of steps of computations and well-defined tasks which you are performing and which you are doing. So this is mostly what we did from our school days. Of course, now it is that machine learning has become so widespread. So we are also, I should not say now it is not traditional. Machine learning also has become very much widely used in different kind of computing, but it's a different kind of computing that you should understand. It is computing by learning, where the algorithm itself, uh, for solving that problem, the algorithm needs to be also learned. The process needs to be learned, which means it involves certain kind of modeling. And given some input-output specification, you do not know exactly what the solution look like, but there are some methods, there are some ways by which you can try to get a solution which will mimic the process, the input-output relationships of the process. So in that way, it is non-traditional in that sense that you are not solving the problem and then designing the algorithms, designing the steps of computations and implementing them, and by which you get the solutions given the input. Here, rather, you are being given kind of data, which means you know what is the input and what is the output, but you really do not know what should be the precise steps of computations by which you can you can establish this relationship of your process. So data is available. Given the input, you know what should be the output if the data is there. But for unseen data, you do not really know what should be the output in that case, because you do not know the process itself. So this is the kind of computations which we will be dealing with when we will be discussing different methods of machine learning. Once again, it just elaborates what I was trying to stress upon, that when you are doing this kind of traditional computations using algorithms, which means it's a sequence of instructions which needs to be carried out to transform the input to output, and this is very well defined, and that can be implemented, that can be run. And so some examples could be sorting. You have different algorithms for the same task, and but for some problems, no algorithm may exist. So those are the problems which we'll be considering the computing by learning, because those are the problems needed to be solved through the learning mechanism, observing the input-output data. Some of the examples could be, say, you are given, say, different mails, and you need to detect spam mails. Now, definition of spam is not precise. It is very much context dependent. It depends upon person. It depends upon the context on which a person is working. So it is difficult to come up with a very precise computing or precise algorithm. So this is the flavor of computing by learning. Here, we do not have any knowledge of algorithm, but what we have rather examples, knowledge of examples. That means we know that what should be input output. So if I ask some person after getting an email just to identify tell me whether it is a spam or not, the person will give you an answer, because with respect to that person's context, person can tell you. But again, as I was mentioning, that it may vary, but there would be some kind of average behavior, some kind of average behavior uh, of a certain set of populations, and with respect to that, we can say, okay, this example is spam and this example is not spam. So that kind of labeling is also possible. It is not that we are always being constrained by a particular context and then only we are trying to solve. It is not that. We are trying to capture the generality also. And that is the challenge when you are learning something. So learning may not be complete always and may not be always correct in every context. But we are trying to develop certain techniques which will be largely correct. So there is there is an approximation which is also inbuilt, which is also implied into this computing. So that also you need to understand. So preciseness is not always there. So that is the play. So here examples could be, there could be different categories. For example, there could be two sets of examples in this particular case. Some positive examples, which means positive with respect to your problems, that identifying spam. So the spam mails, there are say positive examples and maybe negative examples, ordinary mails. So problem could be the text of mail is given to you, even the header or so or whatever structure of the mail is given to you. Then your objective is to mark whether it is spam or not. So this is what you have to learn, what characterizes mail spam. So the task here is more to extract an algorithm. So which means your machine definitely is doing some computations, and those computations are precise because machine is a machine. Machine cannot think and machine cannot change unless adapt, unless you yourself as a human being who are designing this processes, they are making the process in such a way all those things are incorporated. But it is not the machine doing, it is your process is doing, your designing is doing. That is what we are going to learn. That what is the algorithm for extracting algorithms? Something like you can consider. So that is we'll be discussing about the computing by learning under this machine learning topic. So it's a kind of automatic learning by a machine, but don't get swayed away by this the level automatic. Automatic in the perspective of the automation done by our engineering, the human intelligence. So there are certain assumptions that we need to, of course, consider when we are thinking about extracting this kind of algorithms or models of a process given some input output. One of the assumption has to be there that there is an order. See, if you say everything is random, as you understand, the randomness, of course, has again certain probabilistic distribution, etc. So even randomness also we can have some average cases, etc. But still, no, you always assume there is certain, that is the order. So even in randomness also there is an order. So that process, the characterization of that randomness itself is also important part. That how random it is and what is the order, what is the chance of having some given certain input or stimulation, what is the chance, what should be the output. So that is also interesting thing to study. And but we assume that there is a process which has certain kind of order which is generating this data. So this is what, but now whose details are not known. Then existence of certain patterns in the data. So that also we assume, and then given the data, we try to discover those patterns so that it can characterize those process. And it is also, we are assuming that whatever characterization you are doing, that characterization will carry on for at least for some time. Otherwise, no, you are characterizing the process and next time you find that process is also, that characterization also is null and void, then there is, your effort is effort is not effective, and it is not going to do anything. So we have to assume also that no, you are characterizing, and this characterization will remain for at least for certain period of time, on which no you can apply your this method or this characterization to develop certain models. Then approximated construction of a model of the process possible from examples. So this is also an assumption. So we assume that it is possible, and then we try to do it. So there are various contexts of machine learning, and you can see that no, there are different topics itself by which this area is studied. So each topic is very rich, and they have their own flavor. They have their own characteristics, their own engineering approaches. So we need to basically just have a glimpse of some of these topics, some of these broad categories, and then we'll be considering some of the approaches, rather some of the techniques of machine learning which are applied in those different kind of contexts. So one of the thing you have heard, I understand, the data mining. So where you are trying to extract facts from the extract rules, facts, etc. Facts means the kind of general certain patterns, general observations, rules. So that is from a large data set, and you have to handle a very large data set. It requires different kinds of engineering for that also. So it is just not the algorithms and computations. You have to consider the context, that how large it could be, how the data should be stored, how it should be handled, what is your time limit, what could be processor's limit, etc., etc. So those things are there. So a large volume of data processed to construct a simple model with valuable use. So this is one of the things. Some of the applications could be they are predicting consumer behavior, credit trading, fraud detection, medical diagnosis, traffic analysis in telecommunication. You see many applications, what we hear, they are related to handling large data. You can call them machine learning also, it is okay. Machine learning is a very general and very specific. When you are handling large data sets, you need to also understand there are certain engineering approaches in data mining that is discussed, and in that topic you can study them in more depth. Then the other term you might have heard, that intelligent systems. So here it is more on the challenging, there are various challenging problems of, the human intelligence. How are you going to incorporate them into the machine itself? So it is, we human beings are very adaptive under different contexts. So we have learned from our childhood, and it has been now instilled in our reasoning process in such a way that all these things looks very simple for us. I mean, very natural. But the moment you consider them, that a machine would try to do that, you understand that it's a great challenge. I mean, not only the sensing, not only our sensory organs, but also the processing of information itself is also very much challenging. So that is what this artificial intelligence term coined long back. It is almost 80 years back. This term is there, and people are excited at various points of time. At various points of time, people thought it is not doable, and then it has come up once again in this particular last decades, and now you see that machine learning almost becoming synonymous with artificial intelligence, and we have wonderful applications in different sections of our society. Almost in every facets of our society are now driven by some kind of this kind of automated computations, some kind of intelligent computations. So these are different areas like robotics, computer vision, speech recognition, pattern recognition is a generic term, biometry, autonomous driving car, some examples of this kind of thing. So broadly, on one aspect, that you have a very large volume of data and know how to handle that data and then get facts relations. Other cases, it's that you have very challenging tasks of interacting with the environment, with sensors, etc., and how to process them and how to take intelligent decisions like a human person, like a human, or you can say like some super being, human super being. It is not only human; it's a human super being. How the machine can do that. So in a nutshell, so what is a learning problem? If I just consider a bit more theoretically, if I try to address these things, now you can say that in one way that actually why do you learn, say, to do some task, and do some task we learn, and when we do the task itself we also gather some experience, right? So that experience is a kind of learning. So that experience actually imparts learning to us, and we are getting more and more experience, and we are doing that task better. So how do you say that it is better? So there has to be some kind of judgment on that, right? So then only you say, okay, we have learned something. I am able to do this task. Earlier I was not able to do this. I am now able to do this, right? So it is in our human from our schools itself we have seen that now how we have learned, and even as long as we live, this learning never stops, and we might also unlearn many things. Unlearning is also a learning in that way, and relearn many things because we can forget. But no, this process is very dynamic. And but these are three parts, three concepts which are related to that. That there is a task that you need to do. That is your objective. You have to do that task, and for doing that task, you have to have certain kind of knowledge, some experiences, etc. How to do that task, how to get the know-how and do it, and this knowledge you are gathering, and you are improving your ability to do the task. That means the methods and procedures, and that is a learning part. And that improvement part is also very much inbuilt in this process. That means that okay, this is the way I should do. This is the way I used to do, and now this is the modification I should do, so that now I should improve myself, or this task should be better delivered. So these are the three things, as we understand. Say, example, say, very trivial example, that we learn to play chess, and if you think that task is, of course, playing chess, and you have to know rules, etc. But not only rules, then you need to know that given certain situation, which rule to apply, right? So that is what is your experiences. You're gathering experience, you are playing, and different moves you are learning, and you are remembering them at different situations you are facing. So this is the experience you are gathering, and then finally, your outcome you are observing whether you are able to win or not. It's a very black and white way of evaluation. There may be some gray areas of even performance evaluations. It may not be so much black and white. Another example, okay, so recognize objects from a visual scene or an image. So identify all objects. Then accuracy could be a performance, that what is the accuracy of your identification. And then that your experience would be that you should know that which object is what. That means there could be object could be represented in the form of image, in the form of music. That means some sound form. So whatever various forms objects are represented, and there are certain kind of levels, and you are basically learning those levels. That is the identification. So given any object later on, you have to say that what level it is, and that is a kind of. So these are certain things when you do learning, that these questions are involved. That what is to be learned? Actually, what is to be learned? Is it the learning means leveling? Is it the learning means leveling, or is it learning means how to level? Right. So what is to be learned? So how might this be presented? So actually, there are different kinds of questions. One is that if I want to say learn something, I should know that what is to be learned, what form. Say if it is a model, then what kind of model it is. If it is a regression task, what kind of equation it is. So how might this be represented? A target function, set of rules. Am I going to learn? Then how it is to be learned? Now, what kind of algorithms, what kind of process involved, how to use your experience, how to use your data, right? So that is what. And when you think that you have learned, so that is the evaluation part, when it is accomplished. So it is a performance evaluation part, right? Whether the performance improved at a given task over time, and this is what. So naturally, as you see that actually in our context, computing is very much associated with learning, because finally, you are designing an algorithm for that only also, which requires implementation means you are computing. So your computers are computing to learn, right? So this is the relationships between computing and learning. So it is basically you are programming a computer to optimize the performance criteria using example, data, or past experience. So you should look at also in that way. So in a very naive way, you can say many of the optimization process is also a learning process. Very naive way. That is not the whole flavor. So you are building a model described by certain parameters, for example, and execute a program to learn those parameters. Use model for performing tasks, like as I mentioned, optimization algorithms on data. And there are different kind of tasks. Could be prediction of output. You can description means gain knowledge from data, etc. So depending on objectives. A few more examples. I have told about some of the examples, but few more examples I will be just again presenting. Say one kind of learning could be learning association. So finding associations between products. Say it is called also basket analysis technically in that context. So people buying X most likely would buy Y. So it's a recommendation systems. What you see whenever you are doing online shopping, when you buy something, you will find there are a lot of recommendations coming up. And that's a trick by which we are luring consumers to get to buy more products. I'm not saying always luring; you are helping them also. So you are buying one book and you are interested to know more about in that domain. So your system is also suggesting, see, this kind of books. Whenever some people buy these books are also, it has been observed, they are also looking for these books. So this kind of information is there. So that is the association, and whether you can learn that. Then the classification and detections is another kind of task. That spam detection, that is a detection task. There are example low risk, high risk creditors. There could be multiple classes instead of binary classes. Character recognition, biometry, face recognition, outlier detection. Those are certain applications, certain problems. So web applications are particularly, that has become very in this particular the age of internet. Web applications are more and more being used. So we have and many web applications, they have a lot of data. So you know that all these big companies now, that all these companies, Facebook, Google, they collect data, and through their web applications they collect data, and they also learn something to improve those applications or use those applications. So these are already I have told in different contexts. So let me not repeat them. So these are certain examples. Different types of learning. Yes, when I discussed, I just mentioned about learning, but there are certain contexts by which we categorize different kinds of learning. One kind of learning could be that you have already the labeled input data. That means, say, output is your level, input is your data, but that annotation of data is available or labeling is available. So when you have that, then the problem is that if I give you an unseen data, a data whose level is not known, can you compute its level based on whatever data you have, which should be following the patterns or characteristics given within what is inherent in the data sets, level data set what you have. So this kind of learning, we call it supervised, because supervision is in the respect that already these known levels are known for certain examples. So that is a supervised part. So a supervisor has told you, so see, these are the things I am telling you, these are the examples, these are the things. Now tell me that if I give you this example, what should be its level? So something what we do usual in question answering sessions, also in usual our lessons when we did our school subjects. In many cases, certain examples, certain levels are given, and then the child has been asked to say, given this picture, what is its level, right? So, so this kind of question, you can say this kind of set, that's the supervised part. So levels provided by a supervisor. So classification, regression, these are two different kinds of, no, I should say problems, two different kinds of tasks that is involved in supervised learning. In classification, we are just trying to find out levels, but in regression, we are trying to find out certain kind of amount, certain kind of measures. So regression is an example could be like predict the brand of a car given a set of its attributes, something like that. Whereas in unsupervised learning, we are trying to learn a pattern from the data. I mean, labels are not given, but we would like to discover what kind of characteristics are there in the pattern. So, so there are no labeled instances that are available, but data is available. So data is available, and it is assumed that they are generated from certain process. I mean, all are generating from a same process. And what we are trying to characterize, we are trying to characterize that process, the regularities and structures, patterns in the input. Say clustering is one example of unsupervised learning. Clustering, I hope you understand. I hope many of you understand. Clustering means basically that to find out groups of similar examples. So those are kind of clustering. Then another kind of learning paradigm could be reinforcement learning. So here you are learning, and the example is given more with respect to this playing games, where you have certain sequence of actions, and you know that from that sequence of actions, there is a certain kind of outcome, some kind of reward, they say in the technical term, or so it is not that single action, it is a sequence of action that you are going to learn. So you are learning certain policy, that how to, at every point, which action should be taken. But again, all your past actions, your experiences, that needs to be considered, and that sequence needs to be considered when you are designing these policies. So we can give you detail in the case of reinforcement learning, where there is always a feedback. When you are doing some action, there is some feedback from the system, and that is also enriching you that what kind of action you should take given some situations. So these are different kinds of learning paradigm. There are also different other I should say sub paradigms in this context. I'm just telling you the overall some of those paradigms. Now, what is the objective of this course? What are you going to learn in this course? Naturally, machine learning in this course itself, it has a very vast domain. There are many things which can be taught under the same name, but we will be addressing some of them. Naturally, we cannot say. And in fact, there is a course on advanced machine learning that is offered in our department in the next semester. I think it is the next semester. And then there is a course on deep learning. So that these courses have also certain focus, and some of the advanced topics, those are also taught in advanced machine learning. So in this course, we'll be more concentrating on the brief exposure part of the more on the approaches and techniques in some of the cases. So this is what we will have a brief exposure to the theory of computational learning, but it requires involved engagement to learn the theory. I mean, that advanced topics, they handle those things, but we will have a brief exposure for that. Then formulation and analysis of various learning problems. So there are different forms of learning and different approaches, methodologies to solve these problems. So we'll be considering some of them. So when I tell you the topics, then I think it will be more conflict. And we will be considering a few case studies through implementation as programming assignments. So there would be few assignments which will give you some ideas that how these techniques are implemented in computer and how you can solve some of the problems using this kind of techniques. So you can see that this is a syllabus that we considered. These are the topics, say concept learning, decision tree. We'll have some brief exposure to probability, though I understand that you have already gone through this course, but just for the sake of continuity, briefly we'll be giving some. We'll discuss some of the results, major results of probability and statistics, which are used in probability theory data. Then evaluation of hypothesis, Bayesian learning, parametric method of of the Bayesian learning, and then dimension reductions, then instance-based learning, unsupervised learning, linear discriminant functions, support vector machines, artificial neural networks. So last time I could handle up to this. Last two topics I could not handle: ensemble learning, reinforcement learning. I am not sure whether this time also I could take those two topics. So that because of the online teaching, the speed may not be always that fast. I will see if it is possible. We will consider last two topics. Otherwise, we will stop after artificial neural networks. So, what is the background that is required in this case? As you can see that we should have. First thing, it is a PG elective course. So those who have taken from undergraduate, but from the third year onwards, of course. So for them also, I found it is okay. I mean, because they have gone through these courses, and if you have not, please go through the first level course. So you should consider whether you should continue with this course. Otherwise, if you are not confident, you may switch over to another course. But this is a must. You should know these things, these basic level courses of linear algebra, probability theory, discrete mathematics, and algorithms. So particularly linear algebra, probability theory, and algorithms, they are, I should say, they are very much required. Discrete mathematics, the concepts of set, relations, those things you should go through. Then you should be strong in programming. I mean, at least you should know how to program. And programming knowledge in Python you must, because all the assignments you have to do in Python. So that is also another thing, because nowadays, that Python has become the choice of the language, particularly in AI and machine learning. So please learn Python if you have not learned it, and this is a requirement for doing this course. So please take it in this spirit. And as I mentioned, that if you are not confident, then you may switch over to some other course. So what are the books? The first book, Machine Learning by Tom Mischel, that is, I should say, the recommended book for this course. So I would rather request to have a book with you, because all of you are staying in your residences, and it is required that you should have a book. These lectures will not be sufficient, and since the peer consultations, peer discussion is not that much as you had in your hostels when we have here. So please have a book on machine learning and read those books. Just slides and lectures will not be sufficient. The other books also you can consider, like Introduction to Machine Learning by F.M. Alperdin and Pattern Classification by Duda, Hart, and Stock. The first first book and the third book, they are available with our Indian prices. So please look at that and give an order if you don't have that. So you can see that already you know that what is the schedule of these classes. Just to once again mark that point. So we have these class hours, and earlier in the last semester we had an additional hour. But as I understand that all of us are very pressed with this online teaching and many other things. So there is a special decision and special request that everything has to be done within the scheduled class hours. So we'll restrict ourselves to it. Only if I miss any class, so we'll see that now how to compensate. This time I have some of my video lectures. So what I can do, that I can provide you some of the links to those video lectures and you can go through them. So as you are aware that all these classes to be held in this platform, and there would not be any separate email or video conferencing link. This is the link. These are the links. You have to just join the MS Team course page and click the link, and you should find out that on which which the link for which day of the week. So using that link, you can join. Right. So that is what. So let me come to this evaluation part. That is very important for you to know and for us to explain. So we'll have online quizzes in Moodle. So your instead of examinations, what you used to have in the normal classes, normal teaching, we'll have quizzes. And quizzes of 1 hour, and last quiz will be 1.5 hours. So because we have a class on Thursday that is starting from 12, so we may, I mean, at the end, we'll request you to bear with us and have a quiz of 1.5 hours. And then assign, so quizzes, there are 40 marks. There will be 3 quizzes. And whatever marks you get, it will be scaled down to 40. Out of the 100 components, is 40% is quizzes. Assignments, there will be 3 assignments similarly. And assignments will have 50 marks, right? So assignments 50, unless I find a different structure, this components quiz and assignment, this ratio may change if there is a instruction generally from the institute as a policy, then it could be quizzes could be 50, assignment could be 40, whatever. So last time I think it has happened. So right now let us tentatively put it like this: quizzes 40, assignments 50. We'll give more stress on assignments. I will also explain how these assignments will be given to you, how you will be working on assignments. And there is another thing what you need to do. You have to, every week, you have to submit a summary of lectures. There is a form that would be designed for that, and it won't require more than 10 minutes to fill up that form, because there are certain fields only that you need to fill. It's a kind of one-page report in that way. So, but no, you have to submit it, and that submission should be within the end of the week. By the end of the week, that means by Sunday itself. The next week it will not be. You will not be able to submit. This is just to know. This is a kind of you can say kind of attendance what we consider, but daily attendance also will be recorded. And if I find that no, you are missing in the daily attendance list, then no, as per rules of attendance, the registration may be revoked. Okay, so you should attend daily, but this weekly summary of lectures is a must that you should submit. So all submissions and evaluation would be through Moodle server. So you will find your assignment statement in the CAC Moodle server. Note that the CAC Moodle server. I hope all of you have already enrolled to this particular course page in the CAC Moodle server, and then even all our resources will be also available there. Will be available. So these are the few things about that. Now let me again explain what should be the grading policy, because once again because of the online evaluation, and its mode of evaluation is a bit different, and we do not have regular end mid-semester examinations as we used to have. So what my experience is that we should strictly follow a relative grading. So just it's not the absolute marks which will determine your grades. It is basically your performance in relation with respect to the overall average performance or overall performance of your class. So this is what we will be following. That we'll determine the scoring intervals for grades, and it's very simple and straightforward. That there in a distribution you compute the mean and standard deviation, and you can see that how the thresholds are going to be determined. So average, we are considering average grade should be B, and the interval is around that, around average marks, the grade B will be given with certain interval, and from there we determine the thresholds for the grade A, thresholds for grade EX, and other thresholds. So I mean, this is a policy you will follow, and that you should understand. There is another catch, that there is a bonus marks, and these bonus marks is based on this criteria, that if you submit all the assignments and weekly reports and you obtained 80% in both of them overall aggregated, then you are entitled for a bonus of 5 marks. And this bonus, it is applied after computing those thresholds. So you know that after computing these thresholds, this bonus may help you to get the next higher grade. So this is the objective, but no, it has to be. It is strict. It will be. So this 5 is quite a bit. I should say useful marks. What you found. So please be attentive and try to do that. So so this may be may improve your grade even after relative trading. So rules of participations, you are already experienced. Only those who are new, particularly the first year MTech students, they are new. Some of the research scholars, they are also new to our system. So please follow these rules that your microphone muted, video turned off, which you are doing. And if you are asked, please turn them on. Then if you have any query, please raise your hand. Of course, if there is not much of you can also turn on your microphone and ask your query. That is also okay. But when there are many people, then this raising hand would be desirable. Then this is the thing we'll do. Please do not chat among yourselves. Send your query to our TS. One of the things could be that if you have any query, other query, can also bring it notice to our TS if it is possible. Otherwise, as you say, as I have told you, I am very open. When I am lecturing, please, you can also just tell your query. You can stop me and ask any questions there also. And we need to follow discipline to conduct online classes. That is, you should ensure that. This is one thing we are going to be very particular, that you should attend all the classes. And if there is some problem, please inform us. If you are going to miss for some reason, please inform us after priori. It is not that you are not attending and suddenly when I send you a mail, why are you not attending, etc. Then you say some cause, etc. So we are not going to accept that. It has to be proactive from your end. That means you are concerned about your attendance. You could not attend it, so you should inform us a priori. I mean, moment it happened, please inform us. Then come to this assignment submission. Since it's a very large class, what we are doing, that we are considering, last time also did it, you will submit your assignments by groups of 2. So which means 2 of the students will make a group, and then in our Moodle system, we will have the mechanism where these groups only will be able to submit certain assignments. As a group, you will be submitting. Individually, no individual submission. So there should not be 2 submissions for those 2 students. As a group, you will be submitting and you will be evaluated also as a group. So it is pair by yourselves and notify our TA coordinator. So Joyশ্রী is our TA coordinator. I have already mentioned in my mail, and Funny is also there. He is also helping Joyশ্রী. He is also co-coordinator, but primary contact is Joyশ্রী. So I have given her mail and also the contact number. So you should send your group information by tomorrow 5 p.m. because we need to set up all these things, and by weekend we'll have your groups in your server, in the Moodle server. So by tomorrow, please send your group. If we don't receive, we'll randomly do it for them. For those who are not, who are unpaired, who could not find someone, so we'll randomly just simply do the pairing. So all programming assignments to be in Python, as I mentioned. Please note this is very important, and you please maintain the integrity of your submission. And we are very serious about it. That there should not be any plagiarism in your submission. There should not be any copy paste. And please do not help your friend by allowing your content to be copied. Right? So many a time after detections, I hear this kind of explanation that, sir, I just explained, but no, that is not sufficient. Explanation is okay, but that doesn't mean the code should be solved. Right? You can discuss, etc. That is fine. but do not share your code which can be copied easily and which can be submitted. Now that would harm you also, because we don't distinguish between the persons who are sharing and who are copying. The same penalty would be there. So what is the penalty? Penalty is also very quite a bit, I should say. Please, I understand, Shatik, you have raised points. Let me just finish. I will come to this. So the deduction of 10 marks from the total for each copy paste. That means, suppose after computing, first thing is that you will get 0 in that assignment. That is there. It is nothing penalty. It is usual that if we find copy case, naturally evaluation will be, all marks will be 0. And then at the end, when we are making your totals, 10 marks will be also deducted from the totals, and then your grade will be computed. So that's why the penalty is serious, and please do not involve in such a case, because you can get multiple penalty also if there are multiple copy cases. So please maintain that. Even for your weekly report submission also, you have to maintain this integrity. So we consider every submission is very, can consider them in a serious way, and whenever we detect a copy case, we'll take this action. But there is one thing you can do, but it has to be acknowledged a priori. It is not that after I detect, then you acknowledge. Okay, so if you can acknowledge if you have taken help from someone or from other resources during submission. Okay, so this is possible. I mean, in your submission itself, it should be acknowledged. Then marks should be adjusted, right? Marks should be adjusted, means it may be shared, but it would no penalization would be there. So this has to be there, and strictly you have to follow the deadline of submission. No extension, nothing. So whatever deadline we will mention in the Moodle server, you have to follow it. No other excuse. I will listen. So that you have an exam on that day, so at the deadline, because we will be giving your assignment around 3 weeks. There will be around roughly 3 weeks interval. So you should, once the problem statement is given, you can clarify with our TAs by discussion, and please start working and submit it at least before the deadline, so that just to make the things ensuring your submission. See, you may not be able to solve the full thing. Whatever you have done, please submit. If you don't submit, there won't be any evaluation. So that is the idea. Okay, so I am done with this presentation. Now I will take your queries. So I will first ask, I think Shatik has asked a question. I don't find a hand raising. Please. Yeah.
So can you just please move to the previous slide?
Which one?
The previous slide.
Okay.
Yeah, this one.
This one or?
No, the next one.
This one?
Yeah.
Okay.
So I have a few questions here. So like we are making a group of 2.
Shatik, can you introduce yourself first?
Okay.
Because this is the first time we are introducing. Yeah. Yeah, sure. Introduce yourself.
Yeah, sure. Good morning. So I'm Satvik Bansal, third year undergraduate in Department of Computer Science and Engineering.
Great. Yeah, you are from which place?
I'm from Chandigarh.
You are from Chandigarh?
Yes, sir.
Okay, please carry on.
Yeah. So in the first point, you have mentioned that we have to submit in groups of 2.
Yeah.
So like we had a similar situation in our previous semester as well, but the situation for the submission wasn't cleared. So I wanted to clear the thing that if in the group of 2, so should only one person submit the code or like the assignment?
No, one person. That as a whole, the group will get the evaluation. Same evaluation.
Okay, got it. And then in the last point, you have mentioned acknowledge if you have taken help from someone or from the other resources during submission. So like what paradigm does it covers? Like there are some.
The understanding should be the person from whom also you have help. The paradigm is it will be shared mostly. The marks will be shared among you.
Okay. Like you are mentioning if we have concerns, we have talked or like maybe considered a person. But
if it is a copy case, say you can discuss. But no, if there is any, it's a kind of almost if you have used the code itself. Suppose you have used the code not only some person. Suppose you have used the code from external source also.
Okay.
And Sometimes we may also tell you that now you can use certain codes, but sometimes we will ask you to implement by yourselves, because for your learning, we'll be asking you to implement this method.
Okay.
It should not take a code, because many of the models are available already in Python. But this course demands that you should know how to implement them.
Okay, got it.
That's not application, because that is the difference between a course taught from the CS department and from other department.
Got it.
Okay, so you have to implement them using data structures, etc. You have to implement them.
Okay, got it. So in the assignment, will it be mentioned that we are allowed to use these libraries and we are not allowed?
Yeah, you can explain it. You can get explanation from TAs. If you have any doubt, you will get explanation. So may not be everything will be mentioned in the assignment statement, but you can always clarify your doubt, because as I mentioned, when the assignment will be given to you, you will get roughly 3 weeks of time for submission. So within first 2 or 3 days, you should clarify all your doubts.
Got it.
Yeah, I mean, it happens when you make a statement, some impreciseness may be there, we may revise it, we may modify it, right?
Yes,
but it has to come from your end. It should not come at the end. At the end, then nothing will be done. It should come within first 2 or 3 days.
Got it. Okay. And like for the giving the TS the information that we are the group of 2, should we mail them or like message them or something?
Yeah, you should mail them, like Joystree, you should mail them, email. Huh?
Got it. Okay.
Please mail them. Yeah. So with the information of the name, roll number, and others. Yeah. Who is next? Somebody has raised hand. I'm not finding the list of hand raised. I think Shatik, you can.
Sir, excuse me, sir.
Yeah, please.
Sir, I am from ATDC department, newly joined research scholar. My name is Subhash Chatterjee. Okay. Sir, I have another class from 12 p.m. So already link has been sent by.
Oh, it is 12. Yes. Yeah, sir. Sorry. So please, you can leave, Subhashish.
Sir, please take the attendance.
Okay, just a minute. Don't leave. Let me take the attendance. Huh? Download attendance. Yeah, I hope it is downloaded. Okay, so I think we can leave now. Is there any other query? Subhashish, you may leave. And still, I can take some query from the students who wants to stay. Otherwise, no, you can leave.
Because if you have one thing I want to ask, like the meeting is recorded, but where can we find the chat or
it will be uploaded by one of our TAs. It will be uploaded, and you will be informed. Now there is some way. So Funny, are you here? Okay, they will do that. I mean, Joystree will take care. Huh? It will be uploaded. Okay. Any other queries? Okay, so thank you very much. In that case, again, no, tomorrow we'll meet. Tomorrow we'll have a class at 12, and tomorrow we'll start our first lecture on concept learning. That is the first topic that we'll do. And please interact with me. And also, while interacting, first time when you are interacting, please introduce yourself. Thank you very much. Bye.